Imagine this, it's only 15 degrees outside, but your building's air conditioning is still desperately producing 7 degrees of ice water to send to every room. What should I do if the room is too cold? I have to spend money to heat it back up. This is the left-hand cooling, right-hand heating energy waste caused by the offset of cold and heat. The air conditioning of large buildings accounts for 40% to 60% of total electricity consumption. This is an astonishing figure. This means that for every $100 you pay for electricity, $40 to $60 are spent on this kind of inefficient energy consumption. The problem is not that the equipment is not new enough, but that the control is not smart enough. This is the core issue we will discuss today. Traditional air conditioning systems rely on PLC control, which has 3 critical blind spots. Let's break them down one by one. First, it is dead. No matter if it's 10 degrees or 35 degrees outside, it always consistently produces 7 degrees of ice water. It does not have the ability to watch the weather and cannot automatically adjust the most energy efficient output based on environmental changes. Secondly, it is isolated. The chilled water system operates independently from the fan system, each managing its own affairs. The chiller does not know what the fan is doing, and there is no coordination between the two, resulting in low synchronization efficiency. Third, it pursues local optimality rather than global optimality. This is a typical case of picking up sesame seeds and losing watermelons. When engineers manually adjust, they only see that the machine in front of them saves electricity, but they do not realize that this will lead to other machines consuming more electricity. ArchiPilot was created to solve these problems. We don't change the hardware. Instead, we equip your building with an AI brain. Its operational logic is divided into 3 layers. The first layer, digital twin. We first create a virtual model in the computer. This virtual building will instantly reflect the status of all equipment, becoming a foundational sandbox for AI decision-making. Second layer, AI strategy generation. The system will integrate outdoor weather, indoor occupancy, and even time-based electricity prices. The system not only looks at the present, but also predicts load changes in the coming hours, planning the most cost-effective solutions in advance. Third layer, mixed integer global optimization. This is the core. It does not compute one by one like traditional systems. It will simultaneously calculate more than 50 variables to find the global optimal solution for the ice water machine, water pump, fan, and cooling tower. In simple terms, it will calculate, if I spend a little more on wind turbine electricity, can I save more on ice machine electricity? ArchiPilot automatically makes the smartest trade-offs, maximizing the value of every kilowatt. What kind of results does this technology bring based on real data from multiple well-known buildings around the world? After introducing ArchiPilot, the average energy saving rate reaches 10% to 30%. Moreover, the key point is that there is no need to replace expensive hardware or interrupt operations. Because the saved electricity costs are profits, the payback period for the investment usually only takes 2 to 3 years. This is a highly beneficial upgrade plan. How much money does your building waste every year? Let us help you recover those wasted profits with AI. I am Stan from Green Jump. In the next issue, we will introduce the application case of ArchiPilot in high-tech factories. See you in the next issue.